So I kept referring to this anomaly detection tool. Now, this is not customer facing yet, um, but we will take the insights here and bring this customer facing. Right now, it's internal facing, which is really helpful because that brings it to the customer. So our SEs can use this, our support can use this. And what I have here is from January 7th to the 16th, a list of the VM stores in the fleet with the number of anomalies in that time period, the alert bundle count that happened to show up, and the failover count of how many, like when they do a failover. A failover is not always a bad thing. And then I can click in on each of these. Now, I had to blur this out because these have fully qualified names of the VM stores and often will identify customers based on the internal domain names they're using. So what I'm going to do is when I click on one of them, so these are 3 examples that were in that list, and these are for systems that belong to me, right? They're either in Tintri or my like the tech marketing environment. And so what we've done is this is where that training model comes in. And so what we have is a timeline here that's going back 6 months. Now, it was 1 year to train, but it's going back 6 months. Every red line that you see here is an alert bundle has been generated for some reason, right? Now, we have an extensive system already that collects this called ETPH, ET Phone Home, right? And in ETPH, our application already drills in for support really deep on what the alert bundles are, you know, failed disk, failed controller, whatever it might be. And so, but it really doesn't show on a timeline as events. Now here we can see on this timeline that we have, you know, a number of these alert bundles that were coming out. I can adjust my timeline, and then we see these. Now these dots here are, now the data here is really rich. This is 10-second data, 10-second peak data for the last 6 months being displayed down at this granularity for not just like latency averages and stuff for the file system, but specific to the read averages, the write averages. And this is where the anomaly detection, the neural net and the models were created per VM store to find these dots here. Now, these dots mean that something is out of the ordinary. And if we're looking at some graphs, you know, it's really not obvious which ones it might be. Now, most of the time as humans, we could look at this graph here, our RPC average latency. That's our network plus our file system latency together. And we may see that like, hey, there's a spike here, and our eyes would see that. But if they didn't, what we've done by automatically detecting it, not by using hard thresholds, but by finding something that's different, is different to itself, is drilled in and then prioritize these things. So we didn't use any hard thresholds to find this stuff. This was using neural nets and learning models. And what we found was some very interesting stuff where, you know, here's average latency and stuff. And a lot of times when we're looking at it, you'd think that maybe the IOPS would be the thing that was driving that, but it's not, right? It is not the throughput that's driving it. So why are these higher latency than others, right? So this is the kind of stuff that we're getting to now to drill in. On this one happens to be a hybrid. It has to do with flash misses, and so we can get it. Now here's another example. Now here, this one's a little cleaner. Our timeline of 6 months. Let me just drag this out and move it into time frame. So this bounded time frame here, and I pulled these up in advance, so they probably timed out. So just let me hit reload on this. This one may have as well. So let me just hit it.
That's Rob. Actually, just while that's reloading. So there's a lot of information on that last screen. You know, you could see a lot of anomaly points, which, you know, as you said, is based on normal performance. So you're seeing things that sit outside the normal threshold, which you've learned, you know, so the platform has learned that. Is there a way that you aggregate that information together to present something more straightforward to the storage admin? So you could aggregate those kind of anomalies together to say to them, actually, based on all the anomalies we're seeing versus the usual behavior, this is what we think's happening?
Yes, so that's where we're going with this because I don't ever want to make this user faceable. I think that experts can analyze it better than the average admin. We want to save their time and stuff. Don't get me wrong. I mean, as admins, you love to geek out to this stuff, but we'd like to get down to the root cause, the true root, not the symptoms, but the root cause. Figuring out what the root cause is, and then come up with actionable advice. In many cases, it may be, hey, you know what, this workload simply exhausts that system at these points in times. If you took these VMs and whatever scheduled job they have, and we know it's scheduled because they peak at these times, it's kind of normal, and staggered them, then that would make a difference, right? So we could suggest some kind of staggering if they have that level of control of if they're jobs that they control themselves. Or if it's some of the VM stores are cold and some are hot, hey, you know what? The simple step of putting these in a scale out group and let it balance it better first, right? Then you won't have these hot spots, and then it's masked to begin with. So we do want to come up with very actionable advice that user can take without overwhelming them with a ton of data.
You think having experts make the interpretation of this data is a scalable solution? I mean,
it's not. That's why we're training a model to find what experts can find. So what this thing found in that list, which is amazing, was the top list of problematic VM stores. And why are they problematic? Because they got this priority scale number that had a whole bunch of factors put into it. Those factors were derived from me working with data scientists and me saying, this is an example of what crap looks like. This is a horrible performing box. Oh, okay. Put it in the model, weight it different, weight this, weight that. Oh, Rob, when you're analyzing it, what do you usually look for? I'm like, well, it depends. If is it one VM or a bunch of them hitting at the same time? Oh, okay. So they put that in. And what they end up with is the magic of this. This is the coolest part. On this graph here at the top, let me just go back in time. And these are anomalies. So if an expert was looking at this particular system and wanted to point out where it matters, what should you care about on this system, after all the work with the team doing it and stuff, it really comes down to drawing attention to these dots. This is really where something went on. And so what is that? And we can see this green bar. Now, in the very top line here, the primary controller is running on controller B. And then after the green bar, we're running on controller A. So we had a controller failover, but it's a green bar, not a blue bar, because green is good. Like, hey, it was just an upgrade. So the version here was running on 4602, and the version afterwards, 4603. Okay, here was an upgrade to the system. Now, when we have certain spots here. I don't know if I have any examples here.
Rob, just real quick, I think we're going to have to wrap it up. We're going to run out of time.
Okay,
here.
All right. So if there were custom tunables on there, we've also highlighted them. May or may not show on this one. Let me just check. No, I don't see any offhand. So anyway, so the short of it, there is no short of it with me, but we have a ton of data. We are running it through neural nets. We are looking for patterns. We bubble those up. We talk to customers about it. We learn more about what's going on. We have the rich data of knowing exactly who done it. They know the names of these things. As we move forward together with each case that we have with customers, more customers out there, we learn more and more. Now we're trying to take this right to your point and say, yeah, we don't have the bandwidth for experts to scale this. And what we're trying to do is make something extremely scalable that can give that expert advice. And like, I don't have the time of day to go on every single VM store in our environment every day for all of them, let alone every single VM. We want to get right down to the point where every managed object has an expert looking at it all the time. And then at a very intelligent, high level, not just, oh, I saw latency. Hey, you know what? There's a problem here. If you upgraded your network switches, you'd reduce your network latency and things would get better. That's what we're trying to get to. So So this was, I could have used slides and talked vision. I wanted to show you that we have like real stuff, real tangible stuff behind the scenes, and in the limited, without exposing too much, but also showing things that this is the kind of stuff that is that part that you don't see in the product that is happening in all the tech companies. And we all got our R&D and stuff. So.
All right, guys, with that, I'm going to take it back. Thank you so much, Rob. Just as a real quick recap, at Tintri, we're super focused on providing this new level of autonomy, right? So what we consider as traditional storage administration tasks, things like looking at a dashboard and making decisions about whether or not you should add, configure a storage array, those things, we really believe our customers experience this every day. That stuff goes away. And I think we haven't really touched on it because it's not really meant to be a marketing presentation, but Tintri customers don't perform what we would traditionally consider a storage administration. In fact, we're really generalist friendly. All those things that you even kind of attribute to the HCIs of the world or these autonomous storage platforms, we bring that to reality. Our customers don't manage storage. What we've seen over the last hour is how we take that data, that stuff that we've been collecting, and that telemetry that makes up a part of the goodness of the low level stuff. What can we sift through to build deep insights? Again, broaden our purview of the ecosystem, make it more contextually relevant so that we understand what applications, what VMs, what databases are contributing to those anomalies, and then providing advice that's far beyond what buttons to push or what knobs to turn on the storage array. What can we do about providing these ecosystem level optimizations beyond what we've already done at the low level with VM store and TGC?